And now we can start our lesson. Today's lecture number 5. The theme of our lecture: System of tolerances and fits of rolling bearings. The plan of our lecture: 5.1 Design and types of bearings. 5.2 Bearing accuracy classes. 5.3 Scheme of placement of tolerance fields for bearing fits on shafts and in holes in the body. 5.1, and now we can start item 5.1 Design and types of bearings. Rolling bearings are most common in standard units manufactured in specialized factories. They are fully interchangeable in terms of connecting surfaces determined by the outer diameter of the outer and inner diameter of the inner rings. Complete interchangeability of the connecting surfaces allows you to quickly assemble and change worn rolling bearings while maintaining the specific quality of the units. The quality of rolling bearings is determined by accuracy of the connection sizes, accuracy of the form and mutual arrangement of surfaces of rings and their roughness, the accuracy of the shape and size of the rolling elements and their roughness, radial and axial beating of raceways and end faces of rings. And now, bearing terminology. Bearings equal raceway plus rolling element plus cage plus lubricant plus seal. It's equal bearing. Rolling bearing. Radial bearing types. Deep groove. Angular contact. Self-align. Cylindrical roller. Full complement cylindrical roller. Needle roller and tapered roller. Thrust bearing types. Thrust ball bearing single direction. Thrust ball bearing double direction. Angular contact. Cylindrical roller, needle roller, and tapered roller. Bearing selection space. Limited radial space. Choose bearing with low cross-sectional height. X-needle roller and cage assemblies. Limited axial space. First was limited radial space, now limited axial space. Choose bearings that can handle combined loads. X-cylindrical roller, deep groove, needle roller. Examples. Bearing selection loads. Magnitude load. So you need roller bearings, support heavier loads than similar sized ball bearings. Full complement roller bearings support heavier loads than corresponding caged bearings. And radial, some cylindrical roller and all needle roller. Bearing selection lots. Axial. Thrust ball bearing and 4-point contact ball. Angular contact thrust ball bearings. And now we start item 5.2, bearing accuracy classes. Depending on the specific indicators, bearings are divided into 6 classes: 0, 6, 5, 4, 2, and T. The list of accuracy classes is presented in order of their growth. Most often in mechanical engineering, bearings of classes 0 and 6 are used. Bearing of classes 5, 4, 2, and T are used in machine tool building, in the manufacture of devices, etc. For all classes, the upper deviation of the connecting diameters is 0. Thus, the diameters of the outer and inner rings are taken respectively according to the diameter of the main shaft and the main hole. Therefore, the fits of the outer ring with the housing are performed according to the shaft system, and the fits of the inner ring with the shaft are performed according to the hole system. Tolerances and resultant fits chart. For normal operation of the bearing, it is necessary that there is a clearance between the rings and the rolling elements. It is possible to ensure the operating clearance within the required limits only if the fit is correctly assigned and the fit clearance of a given size is maintained, which will depend on the operating conditions of the bearing. Now, in the figure, you can see minimum clearance in the housing or maximum clearance in the housing. Minimum clearance on the shaft and maximum interference of the shaft. Minimum interference of the shaft and maximum interference on the shaft. Green, its tolerance intervals of the bearing, bore, and outside diameter. Yellow, tolerance interval of the housing set, and red, tolerance interval of the shaft set. The choice of fit in the connections. The choice of fits in the connections of the inner ring with the shaft and the outer ring of the bearing with a hole in the housing is carried out depending on the type of loading of the rings. There are 3 main types of ring loading: circulating, local, and oscillatory. With a circulating load, the ring perceives the radial force consistently around the entire circle, which takes place with the relative mobility of the rings and the radial force. With a local load, the ring perceives the radial force by a limited section of the circle, which occurs when the ring and the radial force are relatively immobile. With an oscillatory load, a force constant in direction is combined with a smaller rotating radial force, while the resultant force does not complete a full turn but oscillates in a certain section of the fixed ring. This type of load is as it were intermediate between circulation and local. Selection of feet. The heavier the load, particularly if it is a shock load, the greater the interference feet. Elements will head up differently, causing expansions. Tolerances on shaft and housing. Clearance before mounting and clearance after mounting. And its interference feet between the shaft and inner ring of bearing. And now we start item 5.3, scheme of placement of tolerance fields for bearing feet on shafts and in holes in the body or in the housing. The following basic deviations of shafts and holes in the body are provided for bearing feet. With circulating load for shafts JS, K, M, N, for holes big K, M, N, G. At local load for shafts F, G, H, J suffix S. For holes J, big J, S, H, and G. The location of the tolerance fields of shafts and holes relative to the zero line is shown on figure. At the same time, the bearing feet differ from similar standards general purpose feet in the values of limit interference and clearances. In matching bearings with parts of mechanism, more accurate fits are obtained than in matching parts machined according to the same IT grades. Since the setting surfaces of bearings are machined according to IT2 from IT2 to IT5, and parts according to IT grade from IT3 to IT11. Scheme of placement of tolerance fields for bearing feet on shafts and holes in the body. Tolerance fits its fit between outer ring of the bearing with the housing, with the hole in the housing. You can see clearance fit, it's big F, G, H, H6, H7, or H8. It's tolerance field of the hole in the housing. Tolerance fit in the hole of the housing with transition fits, it's J6, J7, K6, K7, M6, M7. 7, 6, it's IT grade. K, it's a fundamental deviation of tolerance fit, or of tolerance field. And for interference fits, we use tolerance field N6, N7, and its interference fit, P6 and P7. In the connection of inner ring of the bearing with the shaft, we can see transition fits and interference fits. For the interference fits, we use tolerance field K5, K6, M5, M6, N, P, and R, 6 and 7. For transition fits, we use G5, G6, H5, H6, J5, J6, tolerance fields of the shafts. With a circulating load, fits are selected according to the value of PR, the intensity of the radial load on the landing surface. In this formula, F suffix R is the radial reaction of the support on the bearing. B, working width of the set. K1, K2, and K3 is the coefficients. K1, dynamic fit coefficient depending on the nature of the load and overload. K2 is a coefficient that takes into account the degree of loosening of the feed due to the compliance of the hollow shaft or thin-walled housing. Depends on the ratio of the diameters of the shaft or housing. And K3 is the coefficient to uneven radial distribution in double row tapered roller bearings or between double ball bearings in the presence of an axial load on the support. B can be calculated by the formula big B minus 2R. Big B is the width of the bearing, and small r is the radius of curvature of the width of the chamfer of bearing ring. The roughness of the sitting surfaces of the shafts and the holes in the body associated with the rolling bearings should not differ significantly from the roughness of the surfaces of the bearings themselves. For bearings of accuracy classes 0 and 6 with a diameter of matting surfaces up to 80 millimeters, parameter of roughness RA is less than 1.25 micrometers. Permissible deviations from the correct geometric shape of the setting surfaces of shafts and housing cannot exceed half of the processing tolerance. Designation of bearings fits in the drawings. You can see two types or two variants of designation. The roughness of the setting surfaces of the shafts and the holes in the body associated with the rolling bearings should not differ significantly from the roughness of the surfaces of the bearings themselves. Permissible deviations from the correct geometric shape of the setting surfaces of the shaft and housing cannot exceed half of the processing tolerance. You can see two variants of designation of bearings fit in the drawings. First variant, we use nominal diameter of the shaft and inner rings. Accuracy class of the bearing above the line, and under the line we can see tolerance field of the shaft, or only nominal diameter of the feet and only tolerance field of the shaft. In the connection outer ring with the hole in the housing, you can see two variants too. So first variant, you can see nominal diameter of the connection of the feet. Then under the line, tolerance field of the hole, and above the line, accuracy class of the bearing. And second variant, only nominal diameter of the feet and tolerance field of the hole in the housing. Thank you very much. See you on the next lecture.